Welcome to INHE-Module 2, Exam 1, Review with Explanations. As you prepare for your Module 2 exam, it's important to understand how the body functions as a complete system. The skeletal system provides structure, the joints allow movement, and the muscular system produces and controls that movement. When you understand how these systems connect, the material becomes much easier to remember. Let's begin with the skeletal system. Bones are not just hard structures that hold the body upright. They are living tissues that perform several important functions. One of the most important is the production of blood cells, which occurs inside the bone. This means bones are actively involved in maintaining life, not just supporting it. Bone tissue is constantly changing through a process of development and remodeling. Specific cells are responsible for building bone, breaking it down, and maintaining its structure. Understanding this helps explain how bones heal and adapt over time. You should also understand how bones are shaped and classified. For example, the bones of the spine are not long or flat. They are uniquely shaped to provide support and flexibility. Long bones, like those in the arms and legs, have two ends that are important for joint formation and movement. These ends are covered with a smooth material that reduces friction and allows bones to move easily against each other. Without this surface, movement would be painful and damaging. Now think about how the skeletal system is organized. The body is divided into two main regions, the axial skeleton and the appendicular skeleton. The axial skeleton includes the central structures like the skull, spine, and rib cage, which protect vital organs and maintain posture. The appendicular skeleton includes the limbs and allows for movement and interaction with the environment. Bone markings, such as depressions and projections, are also important. These features are not random. They serve as attachment points for muscles and help form joints. Understanding this helps you see how structure directly relates to function. Next, let's move into joints. Joints are where bones meet, and they determine how movement occurs. Some joints allow very little movement, while others allow a wide range. Freely movable joints are especially important in massage therapy because they're the ones most involved in movement and dysfunction. Inside these joints is a special fluid that reduces friction and nourishes the joint. This fluid is essential for smooth, pain-free movement. You also need to understand movement terminology. These terms describe how the body moves. For example, when you decrease the angle of a joint, you are performing a bending movement. When you bring a limb toward the center of the body, you are describing movement toward the midline. These are not just definitions. They are tools used to communicate clearly in clinical settings. Understanding movement also helps you recognize dysfunction. For example, if a joint cannot move in a certain direction, it may indicate injury or restriction. Now connect this to joint conditions. Some conditions involve fluid accumulation, which can cause swelling and discomfort. Others involve the buildup of substances in the joint, leading to pain and inflammation. There are also conditions where the joint structures themselves begin to break down over time, reducing mobility. Postural conditions are also important. The spine has natural curves, but when these curves become exaggerated, it can lead to imbalance and strain. Understanding these conditions helps you recognize patterns in posture and movement. Now, let's move into the muscular system. Muscles are responsible for movement, but they also help maintain posture and stabilize the body. Without muscles, even simple movements would not be possible. At the cellular level, muscles have unique properties. One of these is the ability to respond to a stimulus, which means they can receive a signal from the nervous system and react by contracting. This is essential for all voluntary movement. Muscle contraction depends on specific proteins inside the muscle fibers. These proteins interact to create force. Understanding this helps explain how muscles generate movement. Muscles are attached to bones by connective tissues. Some attachments are more stable and act as anchor points, while others move during contraction. This relationship determines how movement occurs. Muscles also work in groups. Some muscles create movement, others assist, and some oppose the movement to control it. This balance is what allows movement to be smooth and coordinated instead of jerky or uncontrolled. When studying muscle contractions, focus on how muscles behave. Some contractions shorten the muscle and create movement, while others generate force without changing length. Both types are important in everyday activities. Now consider how muscles are controlled. The nervous system communicates with muscles through specialized structures where signals are transmitted. A chemical messenger is released to trigger contraction. This process requires energy, which the body provides through universal energy source used by all cells. Calcium also plays a key role in this process. It is stored within the muscle and released when needed to allow contraction to occur. Without calcium, muscles would not be able to contract properly. The body also has built-in protective mechanisms. Certain structures detect when a muscle is stretched too quickly and trigger a reflex contraction to prevent injury. Others detect excessive tension and cause the muscle to relax to avoid damage. These systems are constantly working to maintain balance and protect the body. Finally, connect this knowledge to common conditions. Some conditions involve widespread pain without visible damage, which can make them difficult to understand. Others involve inflammation due to overuse or stress. Injuries can occur when muscles or tendons are stretched beyond their limits, leading to tears. There are also conditions that affect the neck and posture, often caused by sudden movement or muscle imbalance. Understanding these conditions helps you apply your knowledge in real-world situations. As you study, focus on understanding how everything connects. Don't just memorize terms. Ask yourself, how does this structure function? How does it relate to movement? What happens when something goes wrong? If you can explain these ideas clearly, you are not just prepared for the test. You are building the foundation for clinical thinking.